Hey, how are we all doing? Phew. Another stream. Another 2 minutes late. Well, minute and a half. It's not too bad for me, is it really? We got in there, we got Timothy in, we got Chris. Another stream on the 55. It's not so much about the 55, it's about this bit of test kit that we're supposed to be able to use to trim it with. So Nick has hopefully, well, I'm sure he has come up trumps with this. It's looking good. Afternoon, Matambley, Joe, Michael Hyde, thumbs up, thank you. Nick, sir, hope it works for it did when it left you. I don't mean to say my incompetence will shine through, Nick, and I won't be able to get it to work, but I'm sure it will. Will it ever stop giving? I don't know. There's still doubt, Bob, because I found something else online when I was hunting around for this, for alternatives for the box I built last week, because I built this last week, which was amazing, but it didn't work. Exactly as per Sony's instructions, but it's a no-go. And I think it was down to the FET that I was using, because there's different prefixes to the FET. I've got a P and I needed an E, I believe. And looking at my purchase history, somewhere here I have got an E. So somewhere I've got an E. Just one that I bought from China for about 15 quid, just for one. Bob Anderson's in. Hi, Bob. I think I said hello to you. And Thomas is in. And Susie. -11. Apparently, according to the news, Mrs. Cruncher's just said that that we got a bit of, well, the UK has. I don't know that we're going to get it down south, though. Rob's in. Morning, Rob. Mick McGinn. Rob Titheridge. Sunny, yes. No. He was sunny earlier, it's not now. Nick did turn that round getting that out, didn't he? Hellish quick. I mean, I expect it bothered Nick, the fact that it didn't work, and he wanted to have a go. And I believe Nick did try it himself when he said there was no way it was going to work at all. Oh, it's just done a big jump. Dave Rhodes, hi Dave. The final battle, I don't know. There's another thing. Someone has also had this same problem with it being about 1 kilohertz out and garbled on SSB, which this is. And he found there was a failed track on the board. So he's jumped it when it all worked well. So we might end up doing that. Afternoon, Benji. And Danish is in. Hi, Paul. John Hurd. Hi, John. Yeah, getting there, mate. Mrs. Cruncher went back to work on Thursday, so she's still a bit rough, but getting better. Hi, Mac Vision. Gavin's in. Hi, Gavin. Borley. Hi, Borley. Jess is in. Afternoon to you. Tinu S. How are you? Ann Aston's in. Bit nippy, yeah. Shortwave Radio Test Channel, welcome from Turkey. David Tag, hi David. 80 Hewitt, afternoon 80. And Rob Heads in, hi Rob. Yes, it's my brother's Christmas present from brother, that is. It's out of focus because of the settings I've got on the camera, but yeah, that's a present from bruv. Snow in Ireland on Monday. Was the FET only for low frequencies? I think it was something to do with the. There was one of the things that the designation equates to. We'll have a look at the data sheet in a minute, RV, but it's something to do with the milliamps or something like that, I believe. Hi Les, afternoon to you. It's originally a spectrum analyzer probe. I'll tell you what, it does look really good, Nick, so you've done a good job there. No, Rob. Afternoon, Anthony. Harvey. So yeah, we did look at it last week at the diagram, and I believe it was, I found something on the forum. I can't remember who it was that was said that they'd found something on the forum, but it took a bit of finding, but I did find it in the end. Just trying to see if I can find the oh, of course it's going through all of my computer stuff, not this one. We need last Sunday. Sunday, here we go. Yeah, 7:35 at night was one of the things I found. So I certainly was up burning the what's his name? Burning the midnight oil last Sunday, trying to get my head around why this thing won't work in. See if I can get a data sheet up for it. I couldn't really find a genuine 2SK193E either. There's some in China, but they don't specify that. They specify any of about 4 different prefixes. They won't specify that one on its own. That was the other thing that was the other thing I found. I'm just getting up to speed here. We've also got a bit in from a Ferrari. That's the stuff I get in it. So my mate Stu has dropped me in a fuse and relay board for a Ferrari. So it's going to be fun having a look at that later if we get a chance. Hopefully we will. 2SK193 datasheet, right, that's the one we want. Okay. Okay, so it's this IDSS. So it's the milliamps. Where are we? Are you on that? Yes, you are. So it's this figure down here. So you can see we've got U, E, F, P, K, L, and M. Now, I've got a P, which is 1.5 to 3 milliamps. I don't know what this is. Is this current between the drain and the source? I'm not, as I say, I'm not familiar with FETs really, but the 0 gate voltage drain current, that is 0 volt voltage. Where's the goats? Oh, where are they gone? Goatage drain current. So this is the situation. I've got this 0.75 to 1.5, and I've got 1.5 to 3, and I should have 0.75 to 1.5, and apparently this is quite critical. And I found this on the vintage radio repair and restoration. If I copy and paste it in, I don't know if you'll be able to see this if you're not a member, but you never know. It looks like I can view it without logging in, so you may be able to. So let me pop that in the bottom, so you can have a look through this document if you want to. So there's lots of people saying about, you know, they want an equivalent for this FET to work at 55 megs. And there's a few people you know, saying about different ones that might work. Da, 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 da. So there is some plans here for a MOSFET probe. This one here. If I click on that, will it take it? Yeah, okay. So there's this. A lot of them were saying to use this probe, and I believe this is the one that Nick built originally. And they're saying that this one would work very well to do the same job. So again, if you want the link to that to have a look through that, let's copy that. I ought to put these in the description really, but I just didn't have time this morning. So bear with me, I'll catch up with the chat. So there's somebody here that says that pretty much it's not going to work. So I think a lot of you were mentioning this last week. So it says it would require JFET with it an IDSS within a tight window close to around 1 milliamp because the supply voltage is 5 volts. So it says most JFETs have a widespread, so you'd have to buy a load and do try and select the one that's closest to those figures. So there's lots of stuff. There's something about Miller effect. Now, it's, somebody mentioned Miller effect, I think, last week. So this one here, got very low feedback capacitance. Other JFETs have... And it says here about the coax situation. A lot of high frequency roll-offs, so typical length of coax will probably spoil the performance a lot at 55 megs. So it's saying that if you built that probe that I just posted the link to there, then that would work. And it would probably work with coax as well. There's lots of other stuff, and there was somebody here in the end that said it's very highly that it's not likely to work. But that was a bit of research that I found. And the other thing on the SW55, I think, was this. There was a talk in here about, I'm sure it was this document. Placement capacitors, amplifiers. Yeah, here we are. Self-oscillation on AM. This bit here, very interesting. And it's difficult for you to read this, but again, I'll stick. I don't know if that's going to come out or not. I'll pop this on there, but it does sound like this is exactly the same problem as I'm having with this one. So basically it's very slightly off frequency, stretch, and there's a signal that comes off of one of the ICs. It disappears underneath another one, so it could well be that it's there's some pictures relating to it. So you can see that I can't see what that means, but I think he means you've got to break this track, or there's a problem with this track here. So he's basically put this jumper wire in. I think he's broken the track there, then put this jumper wire in to overcome the problem, and that sorts it out. So it might be that even if we can get this thing trimmed properly with this tool, we've still got to do more investigation. So to solve the problem, this has been translated. Can I get this any bigger? Yeah. Solve the problem is to cut the track on both sides to isolate the section of track that passes under the oscillator coil. Bring the output of pin 7 of IC3 to pin 6 of the flat using a piece of cable, as you can see here, a flat. Yeah, not sure. So the section of track passes under the oscillator coil. There's no oscillator coil there, is there? Unless it means this. Yeah, I'm going to have to study that more carefully, because it looks like he's broken the track there as well. Yeah, not 100% sure, but replacement of the broken flat. Let's say mean the flat flex cable, maybe. Directly to pin 6 of the flat using a piece of cable, as you can see here. So it looks like he's gone, taking a piece of cable there. Yeah, I'm not sure, but definitely this guy's had the same problem. So just a few bits for you to have a look at anyway. I need some finger in me after that. Right, let's catch back up with the chat a minute. Let's catch back up the chat. Radio Caroline's back on air. I didn't realise it had gone off air. SIMAP. Eventually caught up with Mr. SIMAP, who won the Roberts Rambler. And congratulations, SIMAP. Ben, how you doing, Ben? Barry's in. Hi, Barry. Russie's in. Hi, Russie. I have a pee often. Too often, are we? So Nick saying that circuit could never work with only 0.2 volts on the drain, so don't think the FET was the problem, right? So it's just Sony's little diagram never worked then, Nick. I've been hibernating in front of the log fire. It's better outside. Jim, how you doing, Jim? You're going to add a Sony 7600DS to the 2001D. No problem. Yes, this is Clints still, Jim. It's working better, but it's not fixed yet, mate. The circuit was in that tube, but it didn't have much output signal. Thanks for subscribing, Halak. No, you don't. You don't, Ben. I meant you needed to be a member of the forum, not the BVWS, mate. But I don't think you need to be. You can still search on it. Christoph's in. Hi, Christoph. Thank you, Rob. Rob's radio channel. Rob's got a new video out this morning on his next part of his building his radio kit. Afternoon, Daniel. Housework finished? Good. Afternoon, Lee. An auction is underway of old BBC equipment, Gavin. God, there's an old BBC Parival. Amiga auctions. Well, there you go, people. If you want to have a look at that, Amiga auctions. Hi Mike Cass. So what I have got here is I have got a scan of Nick's diagram for his probe. So let's have a look at that, shall we, a minute? Nick can talk us through this. How about that, Nick? So I've just popped that on the scanner this morning, just cropped it in a little bit. But I'll just block it out, don't I? What if I go over this side? Do I block it out over this side, maybe? Where's my number 3? No, oh look, I'm good there. I'm good there, not blocking anything. So I can't point to this because I've got it downloaded as a picture. I don't think you can see my mouse, can you, hovering over that? But this is the circuit that Nick's built, and it's a FET source follower. A FET source follower. So Nick's using a J310. You've got Q there, Nick. That's the drain, isn't it? Q. I think the source is grounded via the 2.2K, and then the probe output is coming into the source. Or coming out from the source. I keep getting myself confused because this is the probe output, so this is the output to the frequency counter or scope or whatever you're going to attach to the back end of it, and this is the probe here. Nick's got 2.2 picofarads in series. Pretty straightforward circuit, Nick, that is, isn't it? But Nick sent me some screenshots of his scope, and it certainly looks to be picking up the signal a damn sight better than mine did. So while you're having a good think about that, I'm going to open a finger up and pop it in me. Crack a finger open. So there you are. That's what we've got. I mean, it's fairly similar looking, I suppose, to the other diagram. Yeah, it's fairly similar, apart from where the output's taken off. That's the difference, isn't it? That's the big difference by the looks of it, is where the output's taken off. So this one, the output's taken off of the drain, whereas Nick's one, it's taken off the source, and we've got an extra resistor in there. So yeah, very, very subtle change there, Nick, isn't it, really? But makes all the difference, potentially. There's a bit of a delay on chat, so I'll pop some more finger in me first while you catch up. In Nick's circuit, VGS is set by the 2.2K resistor, and FET is not in saturated mode. think it's designed to go into a frequency counter, Gavin. I think last week it was said that frequency counter would probably be better than a scope for measuring the frequency on it. So I've got I have got the Radiocruncher frequency counter up there, but I don't know. I've got to try and trace where the power goes. So there we are. Thanks very much for drawing that out for us as well, Nick, because it always helps people to follow along. If anyone else wants to build this circuit, they've just got to refer back to this video. So thanks for that, mate. Brilliant. Great job. Let's get back to the business end of things, and we've got the finger ready to go in. It's traditional now. You bottled your newest beer yesterday, 45 bottles. Oh, what are you brewing up, Christoph? Bishop's Finger's a favourite. You made a pilgrimage to the Shepherd Neame Brewery. Ideal. My voice sounds a bit funny. Afternoon, Joe. So Rob's saying that mine could never work because the way it was biased, the FET was turned on all the time. That's bizarre though, isn't it? Do you think there was a typo, Rob, on their diagram, or they drew it wrong? You know, it appears in probably 5 different Sony manuals. So it's not just a one-off in the SW55. It appears in a lot of the manuals, and it's unusual for them not to have corrected it for the later models, because I think it's even in the 7600 GR, which is one of their last sort of proper shortwave radios. Yeah, it does seem a bit strange. Anyway, cheers everybody. So let's pop Nick's probe up on the camera here. I'm not going to take it apart because I don't want to break anything, but I mean that to me, that's a work of art. That. I'd be very happy to buy something like that, you know. I take it that this is also connected to the body of the probe, Nick. Is it the ground as well? Is the body grounded with everything else? Very short sort of copper pin on the end, look. A nice little bung coming out the back for the leads. He's done me a BNC there to connect to either my scope or frequency counter, and then we've got the power there. So I mean, really, if you look at Nick's diagram, this runs from, well, what the voltage was now, Nick, it runs 5 to 12 volts. So a normal PP3 would work fine on that, wouldn't it? So literally could just solder a PP3 on the end of that, and away it would go. So how are we going to do this then? We could try it on the signal generator again, couldn't we? With the frequency counter. So if you remember last time, the frequency counter was useless. It just wouldn't steady down at all, would it? So I've got 55 megs on the scope. I should be able to probe that. I'm sure Nick can be commissioned to make these for all repairers of Sony sets. £150 each. Now I've got this set up for 9 volts. I thought I'd try it at the PP9 voltage. So I'm just going to clip that onto my power supply. Turn that on. It's drawing 10 milliamps, not drawing anything really, is it? So let's connect that to my frequency counter. Let's pop that on. Now, all I'm going to do is I'm going to clip that to the ground of the BNC on my thing. Let's knock the amplitude down because I'm at 100 millivolts at the moment. Let's try 1 millivolt. I don't know what sort of, what's his name this has got, Nick. But let's clip that on. See if I can touch the center pin. No, I might have to get a clip lead then. This is probably not the right way to do it, potentially, I don't know. So just connecting this up to my SIGGEN. Copper tube is expensive. Thank you very much, Chris. Any word on the DAC 90A? We've got the pot in for it, courtesy of right, so do we need to hit the filter? No. So do we need to up the output of it? Let's try 10 millivolts. Still sort of chuntering all around the place, isn't it? I wonder if we connect it up to the scope direct. Let's pop that off a minute and connect it up to the oscilloscope. What sort of output do I need, Nick, would you reckon? So I need a fair bit of output. So if I fire it up to 100, I think this will only do 100 millivolts. Ah, there we are. Yeah, we got it. We got it on the scopy scope. What am I going to do here? Let's get that one off. Where's me other camera? I've got to reset my settings for the webcam. So I need to just pop this light here off and stick that on there. So yeah, you can see it's a bit far away, but I'm sure you get the gist of that. See if we go a little bit closer. Nope, stay on there. Lots of lights glaring on that, including my reflection, but that's the most it'll do, I think. 100 millivolts is the most this one will do, Nick. So there we are, 55 megs. It is jumping around a bit, but that's due to the cables and everything else. But I've got quite a long cable connected to the scope here as well. If I just go, not to the scope, to the probe itself, if I go directly to the signal generator, if I go directly to the SIGGEN, should we just connect onto there from my ground? Can I get into the middle of that? Yeah, that's better, that. That's a bit more stable. Modulated. Unmodulated. Well, it seems to work. Seems to work, doesn't it? So I think we're going to have to try it on the radio, which is going to take a little bit of setting up. A lot of setting up. Let's just catch up with the chat. So yeah, DAC 90A. John has very kindly sent me in a pot there with the correct switching on it, Chris. And I've also found another UL41. Managed to get another one of those in, so hopefully this one's okay. So we've got a UL41, we got that, so it's just really a case of putting it all back together, really, Chris. But at the moment, I'm a bit snowed under, mate. So I'm struggling to get anything done at the moment. I don't know why. We just can't seem to get nothing done. Copper plumbing tubes, not cheap. Session style beer about 5.5 to 6%. Very nice. PFM meter. Afternoon, Sandra. SW55 time, it certainly is. So let's get the empty finger bottle off. And we've got a grumpy old fart from John Turner to go in a minute there. So actually, is that me on the front? What does it say that? The face says it all, apparently. Grumpy old fart, that. Mrs. Crunchy would say yes, I suppose. Right, so let's just pop that off a minute. Unhook it from the scope. So I need to get the SW55. This is Clints SW55. A Radiocruncher 2006 Pro coming for a recap and an LED backlight repair. No worries, Chris. And thanks for the super chat again, Chris. It's a good label, isn't it? Right, now, how do we leave this? Did I put any screws back? No, I didn't put any screws back in this. So the problem with this radio, it is now working. It wasn't working prior to me repairing it, but it is about 1 kilohertz. Well, it's actually about 0.7 of a kilohertz out now. But we've got lots of bits of wire here to test things. I believe I'm going to have to probe these direct, aren't I? So I don't know that I want those wires, but I'll leave them in for now because I've got to refresh my memory as to what I'm doing here. I'm also interested to see what that modification was that May had done here. You know, I wonder if we have got some problems with electrolyte has leaked and damaged one of the tracks here somewhere. I'm sure it says to pin 6 of this cable, so that's going to be fun to try and do. Yes, it looks like it's in the area of that chip there. There's my camera. You've just seen the camera, Rob. It was pointed at the scope. It's going fine, thank you. I've turned off that light now, haven't I? Let me just turn that light back on. Hands up if you're a grumpy old fart. Yes, yes. Can be, I can be. It's been known. Right, let me have a think here now. What have we got to do here? What have we got to do, Graham? Let's get the service manual back up and we'll have a look at what we've got to do. I don't get angry, just bothered. I get bothered, I get hot under the collar, Harvey. The smoke starts coming out my ears, but it's all bottled up inside, Harvey. It's weird old grumpy farts. Yeah, well, you know, comes with age, doesn't it? Comes with age. You know, we get cantankerous in our old age. Okay, screen cap, cube. Let's fit this to the page a minute. Maybe we won't fit that to the page. It needs to be bigger than that. Bigger. So we're doing this one here, second local adjustment. So we've got to get to the other side of the board to adjust T13. But we need to be probing this side of the board. So I think what we'll do first of all is we'll probe it and see what we've got at this point here. Let's zoom you right in then. It's easier to adjust this with the board on. So this is our servicing tool. So we're going to ignore this because our probe from Nick is going in here. So this centerpiece is different. But the layout's the same, so we've got frequency counter one end, and we're probing test point 58. We've got to set the set to 150 kilohertz AM, and then we've got to adjust T13, which is on the other side of the board, to get to 55.3912 plus or minus 0.0003 megahertz. It's got to be pretty accurate. So that last figure there, you know, that one can be anything from 5 to, wow, 7, wouldn't it? 3907 to 15, something like that. Ideally as close to 12 as we can get, if it's stable enough. So let's zoom in a little bit closer so I can see it as well. So test point 58, I think that's where I've got the little bit of wire attached to. Right by a capacitor. Let's get rid of that wire. Let's get rid of that wire. Can I get the scope in? Now, Rich has very kindly sent me a couple Barlow lenses for the scope, but I can't get my head around them at the moment. I did try them out the other day, but I just couldn't get them to work. It's a lot further away, the picture, but I can't look at the picture through the scope and have that at the same. I don't know. It's very confusing. Basically, to get it to focus, I've got to have it miles off of the workpiece, which means I can't view it through the scope. I don't know. So test point 58 is where we've got to go. I don't know exactly where that is. In fact, I could leave that bit of wire on as an indicator, but I think I will take it off in case it does mess the measurement up at all. So if I zoom you in on the other camera a minute. Make sure you can see where I am. Okay, so the wire we're looking at is this one up here. And that is test point 58 there. It was 58, wasn't it? Yeah, test point 58, 55.39 megs. Daft as a brush. You can't beat a bit of grumpy old fart. Look, there he is. Just one more time for you. Where is he? Ooh, there he is. That's from John Turner. Doc Rubio, and it says there, look. The face says it all. Oh dear. Got my Christmas beard on, look. And my glasses. That is, yes, it's me. It's me. Right. Got lots of things all over the bench here again. Let's get this taken off. I can't remember what that other test point was for there, but we'll leave that on for a minute. I think that's a test point for SSB, so we're going to need to do that because messing with this is going to alter that as well. So there's our test point up the top there. That's where we need to be probing. So let me have a think how we're going to do this. So the set is 6 volts. Let's get that other side of the thing set to 6 volts. Center pin positive or negative. Center pin positive. Let's connect that up. Let's bring that camera back over here for a minute, because it's in my way. Dave, how are you? Don't feel far. Victoria Mildrew. Mildrew, yes. Very good, Bob. Right. So that's going to go in there. Oh, hang on. No, I need the I haven't got the right size cable for that, so I'm going to need to get the actual power supply across. Let me go and grab the 6 volt supply. If I can find the right one. So many supplies for Sonys over here. Plus I was searching through for something the other day and I've moved everything again. Can't remember what I was searching for this time, but it was deep. Kenwood. 3 volt Sony. 4.5 volt Sony. 4.5 volt Sony. 4.5 volt Sony. Come on, what's the 6 volt? There you are. I bought a Sony power supply for the 7600 GR the other day as well. So this is the correct power supply for this radio, ACE603. Just probably don't need that one in at the moment. That's the, I don't want to lose it on the floor. Okay. So it's on 150, which it needs to be. So look, set the set to AM at 150. Volume control arbitrary. I don't even know if the... Bear in mind we've got no aerial connected up at the moment, no Ferrari. Stereo mono to stereo, AM sensor to normal. Stereo, normal, arbitrary means it don't really matter. Let's give him a probe then. Let's get the probe. Let's poke it with a probe. Hang on, I've got about 55 million wires here again. Okay, so let's connect it up to my 9 volts. Let's readjust the camera a minute so you can see what's going on. I think you can see that. Yeah. Now the camera's in the way a little bit, we'll just move that out of the way. Just connect that up, pop it on. And the ground point, so we've got a ground just over here with that shield, that should be okay. So let's touch that point and see if we get a signal. Yes, we do. Look at that. That is dead stable. So it's definitely out. That's because I've been twiddling it. So it's 55, 38, 88, 89 at the moment. So it needs to be 55.3912. So it's definitely out. And if I put it, put another digit on the end. Yeah, okay. So let's pop the set off again. Just turned itself off anyway. So now I've got to get it out of its case. Zoom you back out a bit. Turn it off for a second to save a bit of power. So yeah, Nick, that works great. Thank you, Nick. That seems to be working a treat, doesn't it? I suppose we could try my rubbishy little thing on it afterwards and see if that actually works. Because don't forget, we haven't tested this on the radio yet. We've only tested it on the scope and the SIGGEN, which didn't work. So there must be a fair bit of output coming out of there then. Let me have another glass of the old Bishops. Pop another bit of the finger in me. Okay, let's get the chat back up again. No, it certainly does work, Nick, doesn't it? Letter to Sony, Nick wins. Interesting to see it on the scope. Let's get it trimmed up then, Nick, and then we'll have a look at it on the scope. See what the amplitude is of it, because it does seem like a bloody high signal compared to my scope. I thought that scope was pretty... Oh, hang on, I don't need to take it right out, do I? I need to take this board off. Okay, so this is the fun bit. So we've got somehow we've got to try and adjust T13, which is this. There's a little tiny pot here, look. That one there is T13, that little pot. Let's just go and get my trimmers. It's going to be really difficult to try and trim that. Is it that one there that works? I think that's the only one that'll go in there. I don't think that one will. No. So yeah, it's this pot here. You know, this is why I had that wire attached to it, because I was able to trim it and hit that wire as well at the same time. You think there'd be something on this side of the board that coincides to that though, wouldn't you? Surely it's got to come in on one of these here, hasn't it? You must be able to probe it on the other side of the board, surely. Let's have a look. Oh, it does disappear through the through hole there. Yeah, and that's linked to that pin there. So if I can get that probe on that pin, what if I can get that probe on that pin? We can get it into that via, maybe. We can try it. We can try it. Let's have a go. We'd be on 29,905 now, wouldn't we? And 50. Right. Let's get the camera sorted out. Zoom back out again a minute. Stop the glare on it, that's better. So let's clip on somewhere that's going to be ground. What's going to be ground on this? Should be grounded, I would have thought. Be grounded. So see if I can touch that via there. Yes, I can. So it's got to be 53912, isn't it? And we're going to do this. I've only got two hands here. Can you see? No, you can't see. There we go. Cool, that's finicky. I say that's done, wouldn't you? And what I'm trying to do is flip the board over. Just check that other point again as well. Let's make 100% sure. That says 1.3 there, look. How close is that? 129. Very slightly difference in it, so I need to make it slightly less on the other side. So we'll do 1516 on that side. I mean, that is within tolerance, but I mean, we've got the capability of getting it bang on, haven't we? To be honest, you literally would only have to fractionally move the radio. If I just tap that, I bet that's going to alter it. Typical, isn't it? Dead on 1.2, look. Let's flip it over. Get off. There we are, 9121. How about that? Let's leave it at that. Whew. Got a sweat on now. Spot on. Yep. That's going to do it, isn't it? That's that done. We've still got to do the SSB side of it though, because I think that's going to have altered as well. Yeah, we definitely can't get at that, but I can get at it there, can't I? So we need to have a look at the SSB side of it again. Thank you very much, Nick. That's fingers crossed, touch wood and all the rest of it. That's certainly set that correctly now anyway. Definitely happy with that. So let's go back and have a look at the other part of this. BFO adjustment. Tune the set to 150 kHz upper sideband. Adjust CT1 to obtain 457 plus or minus 0.05 on the frequency counter. So we're just literally connecting the frequency counter directly to this now. This is to the that's the SSB mixer down here, which is what I believe I have my wire connected to. So there's our two. Maybe not then. No, that's the PLL adjustment then. So that's different again. So we need to do this BFO. We'll do them in order. So I need to find this point here, the SSB mixer on the bottom of this diode here, D34, 33. Okay, I see. I'll tell you what, this is not as easy as it looks, trying to find these points on this board. So looking at the board this way up, got two resistors side by side. Where the hell is that? I'm just trying to find that. IC6. Which is IC6? Because it's not marked. Hang on, here we go. SSB mix. I've got it right. I'm going to pop this wire on that one a minute. So I can adjust it when I'm on the other side of the board. So I've got to be on SSB. USB. So I'm on 150 USB, got just CT1 for 457 on the frequency counter. So I've got a wire attached to that at the moment, sticking out the end of the board. So let's go back to the bench. So I'm going to need to pop that one out for a minute. We don't need that one now. We need a frequency counter lead. So 457, that's not very big, is it? Decent ground. It's never a decent ground about when you want one. Okay, so that should be 457. So obviously it's 463. So we've got to adjust CT1. Now one of these is CT1. One is 457. That's this first one here. Right. No, we won't even get down to 457. What's going on? Unless they got them backwards. Let me just try the other one. I don't know if these are interactive. No, we can't even get anywhere near that. Have I got a bad ground or something here, maybe? Try that one. No, that's worse. Trying to find a decent ground here that's a bit closer. That's not really close there, but that is ground. Yeah, 461, 462, that's all over the shop. It's a capacitor, so it's going all the way round. Have we got a dodgy cap there, I wonder? See, we had this problem before and I can't remember what we did to sort that out. So let's just try the LSB. Before it wasn't switching, was it? So the LSB should be 453. I mean, that's flipping way off. Something's not right here. Okay. Perhaps I needed the filter on. So that should be 453. So let's go back to USB. Right, the USB had to be 457 plus or minus 0.05. How weird is that? Four, 5, 7. Right, that's the SSB offset's done. Whew, flipping heck. Okay, so we've got to do this, and we've got to set to 4155. What are we actually on here? Let's make sure I'm actually on the screen. Yes, I am. Let's catch up with the chat a minute. Let's get back to chat for the chat. What was going on with that then, eh? What was going on with that? Ben and Sandra, thank you for the tip. Rolfsin, your Civic's decided it's immobilising you. Dear Rolf. Derek, here but on the sidelines. Yeah, I don't know why obviously the filters sorted it right out, but didn't like it before, did it? Right, let's try the PLL now. You're behaving well, Danish, are you? No worries. Just checking up on you. Just checking up. So next one is this. PLL adjustment. So now we've got to set the set to AM 4155 kilohertz wide and adjust CT6 to obtain 60 megs on the frequency counter. Now, in my experience, this test point here is 6.275. Where the hell they get this 60 megahertz from, I don't know. Because that's where we're probing with the frequency counter, right at the base of IC8. So yeah, not a clue on that one. So I'm just going to adjust my wire across to that point. I'll just pop this test wire that I just done the SSB setup with. Let's pop that back on there. I mean, unless I'm connected to that, I can still smell electrolyte, you know, on this board. There's definitely a test point there. Oh, strange. What's that test point there? It is showing a ground right beside that, so let's connect into that ground beside it a minute. Let's get the wire strippers out. What's this about? 0.8 or 0.6? 0.6, I think. If anyone's wondering what tools etc. I'm using, I have got some links in the description now with links to Amazon products that I'm using. Now, I haven't got it all from Amazon. I do get a lot of stuff from Amazon though, to be fair. And a lot of people ask me about tools, so it's a win-win really. Too bigger. Tip on here really. I've also today put the equipment that I use for live streaming. I've started putting that on there. Again, I get asked about that occasionally, so I put links to all my live streaming gear on there. If there's any aspiring live streamers out there that want to set up. Okay. So we've got to go to, see, I think they've got the wrong point there, to be fair, because that is the underside of the crystal. What are you on? What are we on? Yeah. So yeah, this here is the underside of the crystal. So probing here is just going to give us the crystal frequency. And adjusting CT6 basically trims it to the crystal frequency. So I'm not sure that that's right either. I mean, we can try it anyway. 4155 wide. So let's pop it on. So 4155, execute. Mode, we just want AM. I take it's not. That's a bit noisy. Right, let's come back to the bench. Let's get you lined back up again. So this camera appears to be in the way at the moment, doesn't it? Let's move that one down out there, out of the way. So according to this, it should be 60 plus or minus 0.0005. Well, I just don't see that. So that's reading, as I said, the frequency of the crystal, which should be 6.275. I really can't understand that because, you know, I don't know if what are we on at the moment. Oh, we're on this, but if we go back to this again, if I zoom right in, it clearly says 6.275 megs. Look. So I'm a bit of a loss to why it says AM 4155 kilohertz wide, which I'm on, and how it seems to think that I would get 60 on the counter. Well, there's no way I'm going to get 60 on that if I hit the filter. No. So, any ideas on that? All you learned people? I mean, that's got to be, you've got to adjust that as close as possible to the 6.275. Thanks, Mike Cass. Welcome to the Rangers, mate. Yes, it has had a recap. Anybody got any ideas then? Thanks, Rob. Yeah. So that's the dilemma at the moment. So I'm going to adjust that to 6.275, absolutely bang on the button, and see what happens. And then let me make sure I get the right pot for that. So I'm going to have to get the manual out. I'm going to go get the paper copy in a minute because it's damn difficult trying to look at it online. So bear with me a second while I go and find that. It's bound to not be where it's supposed to be, isn't it? Should be right here, but I can clearly see it's not. I've got the Pro 80 manual, a 2001D manual, both where they should be, but the SW55 is nowhere to be seen. It's probably because it's here, because I've been using it, I expect. Well, I can't find it off the top of my head, so it looks like we are going to be using the one online. Oh, he says knocking the board around. I just need to make 100% sure that I'm going to turn the right one. I really don't want to go back through any more fun and games. Let's find the board layouts. There we are. So I'm looking for CT6. I'll tell you what, this is so small. gonna have to get my glasses on to see it. CT6, where are you, CT6? No, this is the component side. I would say this is the component side. CT1, CT2. Where the hell is CT6? Come on, where are you? You better see my dilemma here. Look, if I go to the screen, CT6 is on here somewhere. CT4, CT3. CT6 there. Got it. It's just there. So there's the crystal. Just above the crystal. What a game. What a game. Oh dear. Right, so it's literally just above the crystal there. So it's that one there. So you won't go. Put the filter on it. Filter's worse. Three. 743 is the closest I can get it. So I can't get it exact. I can see I'm boring you all now, aren't I? But I cannot trim that exactly. And that is the second crystal in there. The original one was even further out than that, and my new one that I put in just totally threw the set haywire, didn't it? Now whether it's because I've got a really long probe, I don't know. Hi Brett, how are you? Yeah, it's bizarre. That just isn't right, that frequency. You can try it on the scope. See what's reading on the scope. Yeah, see on the scope it's reading 2.6, 2.7. Yeah, I wonder if this is dragging it down. Maybe we try Nick's probe on this. Then perhaps. I don't think it would hurt, would it? Would it hurt? I don't think it would. I can't see it hurting. Ah! Chucking the power supply off the bench with the radio still connected would hurt. And let's try it. Can it? Can it? So that's not a high enough level for that to read, is it? No. That's not a high enough level to read. I'm not sure what to do now then, really. Do I adjust it with the scope? If I get you right up in the guts of the scope a minute so you can have a look. See what I mean? Let's have a look at the scope on the screen. You can't see that, it's too close. Let me just zoom you in on the scope a minute. Okay. And for some reason that's not focusing. Come back a bit maybe. Okay. Let's get rid of this light a minute and me. It's difficult to read on the side there. So we're looking at the frequency there. So if I connect up to this, there's the ground. You can see the frequency there is 6.2. You can't read that. Why isn't it reading that frequency? Why can't you see that? I don't know why it won't focus on that. It doesn't like that at all, does it? Let's move it to one side, perhaps. So if I adjust it now, it seems to be making a blind bit of difference. So let's put 274. No. It's all over this shop, isn't it? That's a shocking picture. I don't know why that's not focusing. It normally does. But you get my drift. It does seem that somehow that is dragging it down. It's like that part is almost not working, you know. I mean, there should be quite a big swing on that, but it's not. Could try squirting a bit of isopropyl in it. Is it going to make it better or worse, I wonder? It might have a bit of muck underneath it, you see, because there is a... I've got it turned off at the moment. Because there is a cap right by it that could well have leaked. So we could have a dodgy... Hey Rich, how are you? Welcome, Rich. I've given that quite a few turns. Let's just blow the isopropyl off the board a minute. Give it a bit more twiddly in. Let's try that. No, the best I can get it to is 6.2743 instead of 2745. Let me see what the tolerance is on it. How you keeping, Rich, anyway? I did say I've been playing about with those Barlow lenses, but I just don't know what I'm doing, I don't think. I just can't get it right. Yeah, see, I can't for the life of me find out where they're getting this 60 meg figure from. Unless they're probing a different point. I just can't understand what they're probing. It's got to be a typo, surely. So the rest is IF and RF, we don't need to touch any of that. FM stereo, we don't need to mess with that. Yeah, it's a mystery. So I'm going to look on the block diagram, see if I can find anything that says 6 megs on that. So that's on the PLO, which is there. X1. No. Yeah, I don't know what the hell they're thinking with 60 megs. Well, they were not probing in the right place, but surely that test point is purely to check the crystal. Oh, sent me an email about the Bolo lens. Thanks for that, Rich. I say I've put them on, but the focusing point, like, it seems to be massive, like right up here, to get it focused and in frame. So I'm not sure what I'm doing wrong, Rich, but I'm doing something wrong. Christian, how are you doing, mate? It's not 60, Nick. I don't know where they're getting it from. I just don't understand. I mean, that can only be 6.275 at that test point. I just haven't got a clue what they mean. If we find the circuit for it. So this is the PLL. Oh, where are we? This is where we're probing. This is that test point, and it says there, look, 6.275 megs. Test point 48. So we've got test point 49, but I'm sure it says test point 48. 40 nanoseconds peak to peak. 2.5 volts peak to peak. How they're getting 60 megs there, I do not know. I mean, that's random. Can't be 60 kilohertz, Harvey, can it? Bad as a useless probe circuit. I hear you, Nick. I hear you. Oh dear. Let's put my light back on. It's getting a bit dark there. Ivan, how you doing, mate? 60. It's not 60 hertz, Ivan, I don't think. It's not 60 hertz it's referring to, is it? It's 60 megahertz. If we go back up to the bit where it says about testing it, it's over here. So this is our test point, 6.275. It says adjust CT6 to obtain 60 plus or minus 0.0005 megahertz. There's got to be 60 megs. But you know, we're probing at test point 47. Actually, test point 47. So that is the underside of the crystal there. I am at the right place, am I? I am on the right place. Let me just 100% double check that, because so we've got two capacitors underneath there. Then we've got our crystal. That is definitely the underside of the crystal. But test point 47. Now, does that not contradict the circuit diagram? Let's get back to the PLO. Where are you? I'm zoomed in a bit far now. Test point 48 and test point 49. So I'm on test point 48, but it's saying test point 47 on the thing. So I'm on test point 48. There's test point 49. Where's test point 47 then? Because according their manual's all over the shop. It's all over the shop. Test point 60's down there, the VCO. Where's test point 47 then? Blimmin' leading us on a wild goose chase here, are they? This is a bit crazy. So it's saying there test point 47, which is actually test point 48. If I zoom you right in, that's as far as close as I can go. That definitely says test point TP47. That's where I'm connected. But on the schematic, that says it's test point 48. So what is going on? This is really being a pain in the backside, isn't it? I'm not using a probe at all, Nick. I'm just using a clip lead straight to BNC. That's what I thought. Aston, it's got to be the crystal frequency. What are they doing? And test point 47 is actually test point 48. I don't know. AI. Afternoon, Derek. How are you? Hello, Harvey. You been working today, Harvey, have you? You been out to work? No, it's not, Joe. Something's definitely amiss. I mean, on the board, all that it says, it doesn't say anything there on the board. Yeah, it doesn't say anything on the board. It just makes me wonder, you know, whether I'm probing in the right place here. That's what I'm concerned about. It does say something there, but the silk screen's covered up by the IC. I don't know if that's an actual ground there. It says ground, but I don't trust it. Let's connect that to an actual ground. So you think maybe a scope probe might stabilize it up, Nick? Maybe because I'm just connected straight on that I'm causing problems? I'm just let's try a scope probe on ×10 then, just in case. So I'm getting 6.2748 with a scope probe on ×10. But that's, I mean, that trimmer I'd have thought would have had a bit more swing than that, but it doesn't appear to have. ×1. Yeah, I'm not really sure. It's the PLL output, 60 megs, 500 plus 4. Oh, Radio Birder, how are you? We're okay, thanks, Derek. So, Rich, okay, it's a PLL output, 60 megs. Clearly, that can't be there, can it? Because that is the crystal. The crystal is literally soldered on that point and that point. That is the crystal underneath there. So if we're probing there, that is going to be 6.275. Where are we going to get the 60 meg then? It's got to be somewhere else around that PLL then, is it? Let's just scroll on down. CT6 PLL. We'll see adjustment for it, for sure. Board layout. I wonder if it's got any test points on the board layout. See, that's showing test point 47 as well, look. Test point 41 is ground. You need to think that if it was the output from the PLL we were looking for, it'd be here somewhere. Test point 57. I'm at a loss. Test point 40. Test point 58. Test point 46, 76 kilohertz. No, that's a load of nonsense, that manual. I don't know where that is, and Rich. Yeah, where should I be probing though? So if I go to the PLL, which pin is the output from the PLL then? Let's have a look at the block diagram maybe. PLL. So here's our PLL circuit. Are we looking at pin 11? First oscillator, Q41, first oscillator buffer. SSB switch. No, that's incoming. So what's this 8 here coming out? Apologies if this is making your eyes go squiffy. That goes to pin 44 of the main processor. B plus power switch. Clock latch data, so it's not going to be any of those three, is it? And that's just the reference crystal for the PLL to keep it locked. Low pass filter. I don't know, Radio Birder, I think it's just the same one. I've tried the 10 times probe, Nick, it doesn't really make a lot of difference. I've got the original manual for it, Aston, but it's exactly the same. It does, Paul. Hi John, how are you? Try pin 11. John, hi John, saying try 22k resistor in series with a probe on test point 48. $22k resistor, I've got 22k to hand. $24k. Ah, typical, I haven't got a 22k. I got a 24k. What's 2k between friends? That is a 24k. I mean, it might be barking up the wrong tree totally, and my radio might be working, but I can't understand why we can't achieve the crystal frequency. Maybe we are testing in the wrong place. It's 24k. As you can hear, Maddie's going out for a walk by the sound of it. Just pop this resistor on, see if that makes any difference. And then we'll try probing one of the pins on the PLO. You think pin 11, Nick, do you? Is a good probing place. Well, we're sort of stumbling through problems as we find them, really, Christian. At the moment, we can't seem to get the reference crystal on frequency. And this was always the case. I have changed it for another crystal, which has brought it in a little bit more, but still not as it should be, really. So I'm just going to pop a resistor in, as John has suggested. I'm sure a 24k won't make much difference than a 22k. Let's pop that in. Oh, it has done. So if you can see my frequency counter now, we have got 6.27512. So can we trim that in? So I can now get it to 6.275 with that resistor in line. This is all very strange. So let's pop the board back over. Let's try probing pin 11. Let me see if I can find pin 11 a minute. So that says 1, but I'm not sure, I'm not convinced. 2, 3, 4, 5, 6, 11. So go to that. Well, that stops it absolutely dead touching that one, Nick. If that is pin 1, 2, 3, 4, 5, 6, 7, 11, yeah, it's right on that point there. And that is stalling the radio. But it's sort of reading 57. It's all... Sort of jumping around 57 megs, but it's flashing all over the place. Data that. Ground curve detector. DA. I'm just looking around the test points I can see. S level, B plus, wide narrow, DA, SSB mixer, data. .76 kilohertz. Right. AM. No, I'm not getting anything. Rob, towards the tools, yes. Yeah, the reference crystal is X1. Yeah, your probe, I don't think the signal's big enough for your probe, Nick. We could try it. Let's do it. Let's do the probe. All for using Nick's probe. When he said it won't kill it, I thought he meant it won't blow it up, but you meant it won't kill the signal. Got to be really careful here because it's very small. Oh, well, there you are. Look. It's absolutely bang on 60, Nick. Look at that. Look at that. I'll take it we're on the screen. So there must be somewhere another test point. Somewhere along that line. I hope you can all see that. Let me just get back to my camera because I'm on the screen. Yeah, so that's probing that PLO leg 11. So, in theory, it should be absolutely bang on now. shouldn't it? I wonder where that test point actually is. Unless it's underneath that liming screen there. Sort of thing they would do, wouldn't it? Stick it under a screen. I mean, I can see a test point in underneath there. There is a test point in underneath that screen. If I get you right in close. So this here is the PLL chip. And you see that metal plate there? There is a test point in underneath there. I can't see what it is though. So if I hold this set at an angle, I might be able to see it. It looks like that's unlock. That's unlock, that one. I think that's unlocked, right. Let's pop the power out a minute. Let's turn lots of things off. Let's get the rest of my beer gone. So I'm definitely going to get the grumpy old fart in me now. Ooh, grumpy old fart going in. Here he is. That's brilliant. And there's 3 in the set. One I had last week. And there's a couple more, wasn't there? There's 3 in total in the set. Grumpy old fart. I don't know if it's miserable git or something. I don't know, something like that. Right, that's the sodomite test leads. Now I'm just going to pop it back. I'm not going to connect everything back up yet because I'm still might need to get in there. You know, I'm still not overly confident that it's going to be as good as new. But we have set everything up as good as we're going to get, I think. All our switches are in line. Let's clip it all back together. We should be able to give it a run through like that. We need to connect up an external area and we need to have a look, listen to we need to have a listen to some signals. Let's get the external area over a minute. Have we cracked it? Can Clint have his radio back again? Or am I going to keep it? Am I going to still keep it and play with it a lot more? He had a few too many grumpy old farts, didn't it? TP34 first AM mixer. Some powers. Should work fine now, shouldn't it? In theory, it's been tweaked to hell. It's been tweaked and peaked to high heaven, isn't it, and back. So let's get the because we've got no ferrite connected up at the moment, so we're not going to get anything on the internal aerial. So let's pop the external aerial on. Just still connected up to my antenna coupler, basically ATU. Now what's Volmet, please? Let's try amateurs first. 250 USB. Turn it back to 7 mags. Five 5505.
Copenhagen Castor, net report. Copenhagen Castor at 16200. Automated activation.
Still ain't right, is it?
50 degrees, 13 knots. Visibility 10 kilometers or more. Cloud, fuel, broken at 2,000 feet. Cloud type positive. Temperature 2. Dew point 0. KLH. Tempo from 1730. Cloud, surface cumulonimbus at 2,000 feet. Weather, not report. Weather, received. Net report. Weather at 1600. Wind 20 degrees, 10 knots. 10 kilometers or more. Light rain showers. Cloud, few at 1,200 feet. Scattered at 1,800 feet. Fuel broken at 2,300 feet. Temperature 4. Dew point 1. QMH 1015, will sig. Helsinki, cuppa.
It is working, but it don't sound great, does it? Yeah, it's got very wobbly SSB. Let's just sort this cable out a minute. It's hanging on by just one thread here. So if I attenuate it, it sounds a bit better.
Visibility 10 kilometers or more. Cloud scattered at 900 feet. Ceiling broken at 1,400 feet. Temperature -4. Dew point -5. QMH 0987. Becoming visibility 3,000 meters. Light snow. Vertical visibility 1,200 feet. Repeating.
So if I stick it on DX now, so it starts getting really wobbly. So it's like it's overloading the front end.
500 feet. Ceiling broken at 4,200 feet. Temperature 4. Dew point -1. QMH 1011. No sig. This is Shannon Volmet. Santa Maria, Signet, Tango 05. Valid until 17450. Santa Maria Oceanic, SIR, embedded thunderstorms. Forecast 02340 north, 03449 west, 2014 north, 03308 west, 2301 north, 02613 west, 2125 north, 7 west, 2501 north, 03146 west, 2340 north, 03449 west. Top flight level 420, moving northeast.
See, if I turn it down to local rather than DX, it's like I'm overloading the front end of it. Okay, so 7140. Check all the resistors are good. So I'm just connecting up another radio to test it. So it's LSB, not USB.
That was, I think it's still working exactly the same. It's lovely and clear. It doesn't surprise me at all that he was a broker, if you like. He's very clear and, a lovely microphone. I won't hold it, John. Great to get you the log and a fantastic sounding microphone there. We always buy these microphones hoping they're going to sound good, and you've had one sitting in the shack a long while by the look of it, and no need to buy any more. 5589 DCX 73 there.
These are fraction.
A PX system that I was using at the time. I bought it as a...
Put the aerial back in this one. Okay, no, it's definitely garbled. We're on frequency. I'm happy that we're on frequency now. We're definitely on frequency, but there's definitely a bit of garbling going on. There's definitely a bit of garbling going on. There's definitely some garbling going on. I think we're probably all right on AM, but for some reason SSB is not performing as it should. I'm going to have to get a grumpy old fart in me. Let's go with it. Grumpy's going in. He's going in. And he's, the face says it all apparently. Don't wake up Grumpy, let him sleep. Don't wake up Grumpy, let him sleep. Oh, that's brilliant, isn't it? 4.8%. Interesting stuff. Staffordshire Moorlands by the Great British Seller. Beer's part of the tool chest. Yeah, I need to get a beer holder in on the portable toolkit. And one of those fold down cups. Cheers, Christian. Just let him sleep. There, she's in. I got it in. It's in there. It's in the glass. So, something ain't right there still. We've got the frequencies done. I'm happy with that. Nick's probes worked wonders. As was expected. We didn't try my probe, did we? But, we can do that today now. Must charge that one up as well. Otherwise we're going to end up with it's one of them funny DC power supplies. We're going to end up with a Duff 18650 again. So what the hell is up with this thing? It's working, it's on frequency, but it's garbled. So I think it's something to do with this post that I brought up earlier. So let's go back to this again. Am I on the screen? Let's get my head out of the screen a minute. It says, if you listen to SSB, it's practically impossible to understand the voices. Self-oscillation produces similar to a sort of special water after the sound. You have to check in everything else. The problem depends on the track of the S meter. Problem depends on the track of the S meter, which passes under the body of the coil T12 of the first local oscillator. So it's sort of, it is similar, because it's saying that the electrical variations due to the variations in signal intensity disturb the stability of the first local oscillator, which is what's happening really, because at local it's much more readable. If I flick it up to DX, it's distorted and virtually unreadable, as you heard, garbled. Pin 7 of IC3 to pin 6. I take it he means by the flat flex cable. Let's get a chat up as well. So FM, how you doing? Says your SW55 is exactly the same way. Try other frequencies of the same station, compare. Shannon's on. Bad caps. Monk standing last. Caps have all been done monk standing. You don't really get resistor issues in these sets. So FM is saying that his set, it does the same. Opening another can of worms. What are you saying, Paul? So definitely they're referring to the flat cable here, the flat flex cable. So pin 6. So from pin 7 of IC3 to pin 6 of the flat. Components coupled with certain batches of PCBs can produce a problem, or a PCB with ionic contamination. So the problem is not to cut the track on both sides to isolate the section of track that passes under the oscillator coil. As you can see here, so this is the bit I'm not 100% sure. Cut it there. If you look at other bits, he's cut it there as well. Yeah, it's really confusing. So I mean, that I can see where that is on the board. That's basically where we were messing just now, trying to find the thingamajigger. I mean, to get to track 6 would be fun and games. You probably have to lift this shield. Has he lifted that shield? I can't understand this. Pista taglita lato B. So he's cut the track there. That goes underneath that cap there, but there's got to have been some sort of corrosion got through though and done one of the wires in, surely. So I suspect maybe that's pin 6 there. Maybe he's gone round the corner and out the other side of the board. Cut the track both sides to isolate the section of track passes underneath the oscillator coil. Bring out the output pin IC directly to pin 6 of the flat using a piece of cable, as you can see here, which, okay. This is coming out of there, but I'm not sure what this damage here is. I can't zoom in on that, can I? Can I zoom here? No, it's not making any difference. Zooming back to 100% seems to make a difference, but he seems to have cut this here, or this is damaged. I don't know. It looks like he's gone from the S level point and taken that down to here, underneath this shield. This is, you know, I don't believe I've got any corrosion there. I'm going to get the microscope out and have a look, but I don't think I've got any corrosion there, personally. I'm just going to get the microscope out and have a quick look around the board in that area. See if there is anything maybe I have missed. Let's pop that out for a minute. So, I mean, you can see he's got electrolyte coming through there. So, I mean, if I had a board that bad, I would be testing from that side to the other to see if I've got a break, but no, I see. So he's connecting a pin from that ground there to there. Okay, it's sort of making a bit more sense now. Okay. Tape enthusiast, how are you doing, mate? Difficult beast to tame. John's made a computer simulation. LT Spice of Nick's tool and the one I made. It should work the same if the 2SK FET is not fake. Oh, right, okay, John. Interesting. I haven't tried mine in the actual machine. It's a very difficult beast to tame. It's a bit like me, really. Tape enthusiast. Never buy an SW55. This is the only one I've really had major problems with. But saying that, I didn't think I had any problems with it. It seemed to be working fine. The 2010 is a good bit of kit, to be fair. CRF 320 with the money saved, yeah. So I'm just going to have a quick look with the microscope just in around this area, just to see if there's anything that maybe has got a bit of corrosion in it that I've missed. I'm going to have a look down through the wires if I can. I could connect it up so you can have a look as well. But Rich just sent me something on the Barlow lenses, so hopefully I can get them working so you can see a bit of a better picture. But I've sort of set it so as you can see what I see, so to speak. I've messed with all the cameras, the scope settings now. You know, the problem with these is the capacitors leak and the electrolyte gets down into all the wires, and it's from that you have the problems with it eating away the wires. But this one wasn't really leaking, they were smelly. We sort of just caught it in time, but there was no board damage as such. It's not to say there isn't any board damage, but there's no visible board damage. Right, let's see if I can get Ken Barlow. Have we looked at the schematics for it? Yeah. Right, let's see if we can get you. Where is... Well, it says that's offline, but that's not okay. Yeah, see, that's not in focus at all on that one. I thought I did all that though. Let's stick that to itself for a minute. It's a pain in the neck, this flat cable is a real pain in these. It just loves you. I see it just wants to pop back at any second just to see you again. If I weight that down with a pair of pliers as well, it should stop it jumping up at me. Let's go in deep a minute. Okay, so yeah, there is a bit of corrosion around this chip. I need to come out a bit for you in order for you to see it. Let's see if I can get it so you can see it. Sod me, I don't need to see it, do I? So I'm in quite tight on this now. I mean, I do need to do something about the light as well, but I don't know if I can see through this myself. If you can see here, there is corrosion around that IC. You see me just... Yeah, there is a bit of corrosion around there. Well, it's not corrosion. Don't get me wrong. The pins don't look corroded, but See if I can focus it a bit better. Wrong way. Up there. Yeah, the pins aren't corroded, but there is something in there with it. So I wonder if that's got issues elsewhere, you know. There's definitely a bit of muck come through somewhere from something. One of those wires has let some muck through by the looks of it. Oh. These aren't the easiest of sets to work on, I must admit, but when they go in, they do sound nice. It's a nice set. This is the only one that I've had that hasn't worked after a recap. Okay, so that's cleaned it up a bit, but there was definitely something lying underneath that. Somewhere something's come through and spewed up on there. So maybe matey has got a point. You know, maybe it's leaked out from underneath here. Maybe it's come through that via there, you know. Because there's a via just here. There's also another one over here that it could have come out of. So it could have come out of this via. Over here, it could have come out of this one down here. Could have come out of any of those, really. But I mean, the tracks look fine to me. I don't know if there's any wires actually physically underneath. I mean, this is just an amplifier, an LM358. But it does say VCO. This here is the VCO test point, I assume. Is that a bit of muck on that one as well? No, it's just a... I'll tell you where there is a bit of muck though, is down there, look. There's something there. You can't quite see that, can you? If I move that slightly into the camera more. See what it says D3 there? There's definitely some muck in that. And if I zoom right in, you're probably going to lose the... Just let me get it on in focus a minute. There's definitely something in that via. Can't see it with the naked eye, but you can under the microscope. Have I got a very fine... See if I've got a very fine capacitor leggy that I can stick down through. It looks big on the screen, but it's not. It's very fine. Piece of copper, strand of copper might go down there. Don't think I've got a fine enough capacitor leg to go down there. Let's try that. I poked it through, whatever it was. You could be right about the IC, Rob, could you? What's your thoughts on the IC, mate? Because I can't see what you're writing at the moment. See, this is electrolyte, not acid, don't forget. So, sorry, it's acid, not alkaline. So it's not like battery stuff. You've got to use something to flush it out with. So I wonder what's directly on the other side of that board there. I wonder. Let's get the microscope out of the way for a minute. What are you going on about, Brett? Oh dear. I don't know what Rob's going on about. IC. What IC? I don't know what you mean, Rob. It's an amplifier. It's not going to be the IC there, but it's potentially some grime that's got through. We need to try and test from front to back of the board, which is a real pain on these. You've got to basically test all the vias, but I didn't think there was that much corrosion on it, but looking under the microscope, there definitely was corrosion underneath there. So where am I? Where? Yes, there's no capacitors near there. Let's have a look at this side of the board under the microscope then. Could be back to the drawing board and looking through all of the wires. Well, you just enjoyed that blockage being removed, did you? Yeah, Rob, know that the main processor is the brain usually, but we're not even on that board. This is the PLL and the signal board. So we're looking underneath this area here. So I mean, there's a load of wax and that on there. I suppose I have heard before that wax, and Les has told me that wax can go bad and cause problems. It can get contaminated. So here we are on the other side of the board. Just looking for any nastiness. So, you know, you can see, where are we? No, we're over there. Yeah, so you can see that this one is one that I've changed. So we're over it more to the more up this way. More in this area. So there is a bit of something on the board there, maybe. Of course, it can be muck got into these trimmers. I don't know what these two do. A couple of little coils there. The mate was on about one of the wires that goes underneath this coil, didn't he? So we've got tracks going underneath this one. So it could have pulled up underneath here. It does look a bit discoloured around this one. You can't quite see that. If I move it slightly up. Yeah, I'm just looking at this one here at the moment. I don't know if I can alter the brightness on this thing or not. Brightness, saturation, black stretch, white stretch. Alpha. No, don't like it at alpha. General. No. Oh well, no, I need to get the software for this thing working properly. It's not working properly. So I'm sure you can see it's a little bit dull around this one. especially in here. So something else got in underneath this. There is tracks underneath this one, so I wonder if this is the one that he's talking about. Yeah, that does come up in the area of that. Does come up in that area. Doesn't look like it's that easy to lift though. I could probably lift that with a soldering iron, really. The problem is it's got such fine wires connected to those pads. Asking for trouble. I mean, I don't know if I can get in any closer and still let you see it. Let's see if I can focus it for you. I need to be down a little bit further. It's easier to move the piece than it is to try and move the microscope. But you can see the fineness of the wire there coming out of that coil. If I put the tips of my tweezers in there, which are very fine pointed tweezers, you can see how small that is. So it could be that there's got to be a wire, because I can see a track. I can see a track coming down. You can see various tracks coming down. There's one just there that you can see coming down in underneath this. And there's another one. There's a wire just underneath there that I can see. And we got corrosion and muck on the legs there. I wonder how easy it would be to get that one off. I don't want to do it with the hot air because it's plastic, it'll just melt it. Could try wicking away some of the solder and see how we get on with that. I put bent tip on. I'm not going to spend a massive amount more time. I want to have a quick look at that Ferrari, the Ferrari board, before we shoot. So I want an hour to play with that really, and we've got 45 minutes left. So I'm going to have a go at wicking off some of this stuff and then see if I can lift it. What have we got coming up here now? Blooming rubbish. Pop-ups all over the place, isn't there? No, I don't want to see what you've got to offer. So I'm just thinking if I try and just wick. The solder off, I can't see because the microscope's in the way. Oops. Let's zoom back out a little bit. You might be able to see what's going on. I might be able to see what's going on. Be nice if I could see, really, wouldn't it? That's better. Okay. So I've wicked the solder off. I thought if I put a wider tip on, I might be able to just lift a side at a time, if you know what I mean. If you know what I mean. Right, where's my soldering iron? Right, that's got that side gone. So it should just be a case now of sticking the soldering iron in there and sliding it across, but I can't because the microscope's in the way, so let's go back to that. Take the microscope out of the way and do it by magnifying glasses. And I've got to turn the board around as well. No, you don't want to go. You don't want to go. There he is. Got him. Yeah, it doesn't smell great. Let's get back to the microscoping tool. Let's see what massive hole I've just burnt in it all. No. So yeah, they're it's looking a bit mucky, isn't it? There is wires underneath that. Tracks look fine to me though. Yeah. So the other one is this one. I'm not sure whether there's a via. I mean, there is a track that runs underneath that one. There's two tracks, but I think maybe that via there connects to one of these legs. Yeah, not sure. How are you, League? Hi, Martin, how are you? Very fiddly? Yeah, it's always fiddly. It is pretty fragile. So yeah, I'm just looking at the which way am I going with this? That way. Yeah, I'm just looking at the vias going underneath this one as well now. So you see there's a very fine track. Disappears underneath it there. It looks like it connects that pad to there. Let's have a look. See if that is the case. If I can untie my meter. So let's just stick it on buzzer for a minute. I mean, really, we should look at the continuity on it, but just being quick. So I reckon from there to there. Okay, maybe that's not connected to there then. Maybe that's connected to there, perhaps. No, maybe there's a via underneath this one, but I don't recollect a via underneath this one. Just use what you got, Christoph, innit? I mean, a microscope does help with this sort of stuff. Ooh, yeah. See, I can't really see now. Yeah, so there's electrolyte. There is electrolyte on the board. I mean, some of it's going to be flux from where I was soldering, but could be anywhere in this area. Basically, I'm going to have to go through and check all of these vias. I'm going to have to take components off. It's a minefield, that is. So we know we've got it on frequency now, thanks to Nick's tool, and I will see if my tool actually works, because we'd never tried my tool in anger on a set, but not at this stage. I've got too much of it disconnected now. So yeah. The pain in the backside board still persists I mustn't forget that I've got that little tiny coil to put back on either. But I can't put that back on until I've ohmed out all those connections, all the wires, to make sure they're connected both sides. So I'm going to have to go through all the wires. That's the only thing. I'm going to have to go through them. Thanks, Rob, for the soda wick. I can't get you any closer in on this camera, but basically every little tiny black dot you can see there is a wire. So there is absolutely hundreds of them. And it's in the area where the solder, where the electrolytes leaked out of all these. And I mean, it's not terrible. I've had a hell of a lot worse than this. In fact, this is one of the best condition ones I've had. Yeah, it's got through somehow and done something somewhere. I'm quite interested to see what that post is going on about. So I'm going to pursue that further, just have a look at what he's done and what he's found, and just ohm it out and see. But I've not got any continuity between there and there, which it looks like that track goes up and underneath this one. So I've got no continuity. Ooh, someone walked on me great between there and there. So let me get a little baggie to put that little tiny miniature part in. You can bet your life the first thing that'll happen is that'll drop off the bench onto the floor, and that will be the end of that. Be robbing more bits off of my poor spares set. That's not really a spare set. It was a restoration set that's turned into a spare set because I pinched the crystal out of this one. Put that to bed. What was I looking for? A little tiny bag. So it's progress. It's progress, but we're not there yet. That's all we can say. Progress, but we're not there yet. Bit like British Rail, isn't it? Oh dear. It used to be their slogan, didn't it? We're getting there. So Clint, if you're watching, your radio's still not fixed, but it's working. Just don't work very well on SSB. Right. Let's have a quick look at this this pièce de résistance. Let me go and grab it from downstairs. The Ferrari board. I did promise I'd have a look at this week, but it's just been mental again. I'll be there in a minute. Maddie's coming to see where her daddy is, look. Daddy, where's my daddy? I want my daddy. Here it is. That's a bit bigger. I won't need the microscope for this, will I? I won't need the microscope for this. I think I'm going to need to go through all the through-O's, Christian, in that area just to check. It's only a dual layer, double layer for tape enthusiast. Catch you later, Brad. Cheers, mate. So this is, I don't know if you can see the logo there. This is a Ferrari relay and fuse board. I mean, look at this thing. Whoa. It's coming from my mate Stuart. I did put a link to his Instagram page in there, but this is what this has come out of. So this is Stu's car alert. So this board is not actually out of this one, it's out of another one that he's got that's been a donor for this, but I think he's hoping to sell this board on, so he wants to just make sure that everything's okay on it. But yeah, that's a nice bit of kit, isn't it? That's a nice bit of kit. I'm going to have a bit of grumpy old man again in a minute. I'll let everyone catch up. So I've got no means of powering this thing up. I mean, it's got multiple connectors that plug into it. There's one goes in there, two here, and another two here, and the three here, and a couple big ones up there. So I can't put power on this really to test it. Now, I just assume that these are all pull-out relays, but I don't want to give it too much stick. There's a little bit of corrosion up on some of these here. Yeah, I think they are plug-in relays, but you'd have to have pretty tiny hands to get them out, wouldn't you? Yeah, they are plug-in relays. So it's just a case of going through this thing, really, and trying to take it apart. I mean, are they all the same relays? They're probably not, are they? They probably all do different things. I mean, they're all saying they're 30 amps. Different part numbers, though. 113, 113, 113, 101, 113. So, yeah, I'm not going to be able to get these mixed up. And what have we got here? Is this a relay as well? The pins don't look corroded, but certainly we can put some stuff. I mean, there's certainly a bit of corrosion on that, isn't there? Even from Barcelona, no finger about. I've had the fingers already gone in me, dids. So it's had got some water on it or something. I think there's been a little bit of corrosion on it. I'm going to take that, pop that one out. It can only go in that way because it's keyed. Don't think it'll go in that way, will it? No, so it's keyed. It looks like the back's already been off of this, so let's have a look. What size are they? Let's get a little tub to put these screws in so I don't lose them. Your brother's an expert on cars. Has he got one of those? Has he got one of those, Rob? Has he done any work on those? That's a lovely bit of kit, isn't it? I did put in the description what it is. Catch you soon, Martin. So let's have a look in underneath here, see what goodness there is. Does look a bit crusty, doesn't it? Copper's delaminated there a little bit. Definitely got a bit of delamination there, but it's all connected, it's not cracked. It's a bit, someone's had a bit of a go there, there's a bit scratchy around there. I think if you start undoing all these screws to get the board physically out, every single one of these relays would have to come out, and all the fuses, I think, in order to lift this plastic cover off. Yeah. Not to say they couldn't, and we got a fuse missing from the end there, but that might be an accessory that's not being used. But yeah, to get to the other side of the board, I mean, would it even come off? I mean, it just looks, there's a little bit of corrosion around here, but nothing major. Let's just try a little bit of isopropyl on it and see if that makes any difference. Fixolantia Stratus, I remember those, Christian. They were cracking rally codes, weren't they? Resolder and look for cracks near the solder pads. Italians have tiny hands. Oh dear. What's that in the camera there? Oh, it's my cup. I wonder what that was then. I thought it was something stuck on the side of the screen. I don't know what this brown stuff is on it, but it is coming off. Whew. Smells petrol-y. White spirit, maybe? But someone had a wipe on this with some white spirit, probably. It's almost like this is like a flex. Can you see how it's moving as I'm pushing it that? It's almost like this is a flex board. I mean, you can see where I've cleaned it there. It's come up quite nice, but yeah. 300,000 euros for Stratos, Christian. Flipping heck. John said, before taking the readers in, make yourself a little test jig for them. 12-volt supply, 4 to 5 amp, and 30, 40 watt load, bulb or resistor. Yeah, a little, I've got a little lamp here that I use for testing power supplies. That might do it, Christian. Got a little indicator bulb that I use for power supplies. Oh, that's rated at, actually. I can't put them in see. I can't see anything these days. "21 watts, 12 volts. 21 watts, 12 volts. Look. I've got a DC load as well, so I could load it up with that. It looks like this is some sort of flex board, or it's completely delaminated. I mean, there's fingerprints on it that aren't mine. Sounds a bit crispy down in there. Yeah, this is a little thin flex board. Oh dear. And it smells like someone's... don't know what someone's put on it, but I can see it squidging around inside. I mean, I assume all this brown muck is just flux. I mean, can't think what else it could be. But yeah, there's definitely some nasty stuff got in there. I think the whole lot's going to have to come apart, you know. I think the whole lot's going to have to come apart. Has the white spirit dissolve the glue holding down the copper? I don't think so, Rich, because it's like a flexible board, but it's a two-layer flexible board, if you know what I mean. It's like the old ones they used to use for the keyboards. Where was it particularly flexy? Yeah. So you can sort of see it up here. Like if I push down, can you see that flexing? But I think there's two boards sandwiched together, because I can definitely see a trace in underneath that one. There's a bit of I was trying to see if I can get it in without the light glaring on it. I'm just chucking stuff all over my lap here now. You can see there's some corrosion in around there, but it doesn't seem to have done any damage to this side of the board. And all this brown stuff, I think, is just flux. I mean, look at the state of this area here. So I just get let's get a cotton bud. Just go in that area there. See, it's coming off. I think it's just flux, you know. I think there's anything sinister on it. Assuming that's come up. That bit I've just done there has come up fine, that. So that, it's got to be just flux, that. Seems to be a lot of flux though, doesn't it? Or some sort of cleaning stuff that someone's put on it, maybe. I think you're right, John. Yes, it is. Like I say, it's. I think we've got two flexible boards, one on top of the other. Yes, let's pull one of this one out, for example. See, the pins seem pretty good. Made in Spain. I don't know which one's which. I'd have to look them up to find out which is the switch and which is the coil. I can see a coil in there actually through that hole, so it might be those two outer ones of the coil and the center ones of the switch. I don't know. Let's have a look. So relay is just a way of switching high amperage circuits with a lower voltage, so the coil's activated and that flicks the switch. 81 ohms. So yeah, I reckon that's probably the coil. So that's open. And that's closed. So when you put power on that, it's probably switching from there to there. Yeah, that's normally closed then, I would think, those two. It looks like that's normally closed. That's our coil between there, and that must flick the switch when we activate that to power that up. You can check that with a 9-volt battery. A 9-volt battery will normally flick them over, won't it? If I can find me 9-volt battery. Which I've probably tidied up. It was here because I was using it for... Oh, there we are. Diagrams on the side of the relay. Oh, yeah. You can't see that because it's all gammy. Let's give it a wash, a wipe over. I've picked one of the ones that's got the worst diagram on it. Right, it has got a diagram on it, but I mean, I can actually see it in the camera better than I can see it with my naked eye. How weird is that? So 85 and 86 are the motor. Yes, that was right. 87A and 30 are normally closed. Yeah. And 87 so I got that absolutely bang on. 12 volt, 20 stroke 30 amps. So we should be able to flick it across with a 9 volt. So that's my leads. But see if I can find a 9 volt battery clip. Actually, I can just connect it on, can I? Is Nick still about? Positive, doesn't matter which way around it goes, it's just a coil. So at the moment we're in buzzer mode. There's no connection. So if we go to there, so if I hit that one, it should. It's not buzzing. Why ain't it buzzing? It's definitely clicking across. And we've got the connections wrong, so let's have a look. Let's go that way. I mean, that's not putting it under any load, but it is switching. Rough and ready, but I've put you to sleep, Paul, does it? That's nice, isn't it, eh? Nick even. I put Nick to sleep, look. Ferrari work is beyond your skill level. Catch you soon, Paul. It's not Ferrari work, it's just electronics, isn't it? It's basic. Basic electronics. Yeah, there isn't. I really don't want to start messing about with these flex boards. I will clean all the flux off the bottom. I mean, that's come up quite nice where I've started cleaning it, if you can see. Just in here. That's come up quite nice. There's a little crease in it there, look. Almost looks as if someone's had the board out before, but this board doesn't really seem to be attached to much. But it's like, I can't remember who said it now, it's like a keyboard membrane. Because there's that many connections, it might even be 3 boards sandwiched together, I don't know. But this would be an absolute nightmare. There is one dodgy connection there. I think my best bet is to go through this, clean it all up. Clean it all up, get all this flux off of it. Give it a spray of PCB lacquer to seal it all back in. And get the relays out and test them. But saying that, mechanics can test relays, can't they? Let's get rid of some of this corrosion. And then just put some deoxit on all of the connections. Just deoxit them all. Probably use the little needle one just to go into all the little slots. Plug them in and out a few times. I say they don't look corroded. The only one that looks corroded is this one. This one looks like it's had a bit of trauma. This one. Yeah, that one's a bit grotty. So we've had a bit of corrosion on that one for sure. So there you are. The NC, normally closed contacts, seem to have high resistance. Reflow all the visible solder joints. You really don't want to with one of these flex boards, Tim. You know, it's difficult to show you, but there are two boards sandwiched very close together. They're showing signs of corrosion between the layers. I mean, you'd have to get the boards out, you'd literally have to desolder the whole lot. There's hundreds of soldered points there. You have to desolder the whole lot to get the boards apart. I'd be there for days doing that. Be there for days. The normally closed contacts seem to have high resistance. Yeah, I'd need to do it on the proper bench meter, I think, John. Null it out and just go through and check them all, make sure the resistances are all okay. But certainly I'm going to have to take all the relays out and check them. I don't know what this thing here is, some plug-in module. I'll have to look that up. Made in Italy, that bit, anyway. So there we are. I think that's pretty much come to a conclusion today. We've done the probe. We've done the frequencies. We know they're all okay. So it's just a case now of going through and going through all those wires, checking them all. I'll have a look at Matey's. I'll really get my head into what Matey's suggesting on that post and see what we can do. Which contacts did I connect the 9 volt to? I connected them to the two. I connected them to the coil SIMAP. That was 85 and 86, which is the two outer ones. You can't really see that with that camera, but if I pop it back on this one. And if you look on the side, I've cleaned it off a little bit better now. You can see that it says that's the coil there between 85 and 86. You see that's the normally closed. It flicks across to 87 when this is activated. So the coil is the two outer ones there. And that's a switch in through the center, 3-position switch. Well, you've got a common, haven't you, and normally open, normally closed. But yeah, we need to go through and just lube all them up, clean up the back. Let's say we've got a couple crusty ones down this side to have a look at. And if you saw that one, but that one there, when I pulled that one out, that's pretty crusty. I would say probably just change that one anyway, because they're not, I mean, you can't see it very well because the camera's blown out, but there's definitely corrosion on that. But yeah. Yeah, Nick is the construction king. Cheers, Les. You're welcome, Simon. There we are then. That's it for today. Shall we do this SW55? Now, I have got another SW55 in here in the queue. So at the moment the queue is, I've got 2 radios in for Clint. This one, which has bounced back, which I thought I'd got rid of, it's come back. I've got an amateur radio in for him that's lost its connection with the head unit by the sound of it. I think that might be a bridge too far, that one. I think there's potentially a component gone in that, so irreplaceable. But we might need to get hold of Kenwood for that. And I've got a Pro 80 in, which has got no audio output whatsoever. Someone's connected the caps the wrong way around in that one, so I'm really not sure what I'm going to find there when I get into the guts of it. I've got another SW55 in for a recap. What else have I got? I've got loads of radios for Chris to get sorted. So yeah, plenty on at the moment. Don't ask how you know. Yeah, that is very fragile. So yeah, thanks again to Nick very much for doing that probe, Nick. That's a great bit of kit. Worked bang on, didn't it? Absolutely perfect for the job. So yeah, bit of a head scratcher, but got there in the end. So thanks for that, mate. So I will see you all next Sunday. So have a good one, and bye for now.